Okay, welcome back. ECO311 Chapter 10. So just to recap on the detection methods. First one, high R squared but few significant T values. Or you can say high R squared but the presence of quite a number of insignificant computer T stats. Strong correlation coefficient between certain pairs of explanatory variables. And then you run the auxiliary regression. And then the R squared of the auxiliary regression, at least one, is greater than the R squared from the original overall regression. And then the last one, the VIF variance inflation factor, remember to substitute the right R squared from the auxiliary regression. If any VIF is greater than 10, then this is the fourth way to detect for the presence of imperfect collinearity or imperfect multicollinearity. So if you look at these four detection methods, luckily they don't involve any distribution tables like T table, F table, chi-square, and so forth. But you can't avoid the reality. It is going to happen when it comes to the detection methods for chapters 11 and 12. And then for the last one, the remedies. I'm going to stick with this regression that we have been using. And there are 6 remedies, and I recommend you a way to remember the remedies. And remember, you can't just remember the remedy, you need to refer back to the given information. So the first 2 can be remembered together. First one, you decide to do nothing because you are scared of committing underfitting. So you might wonder, oh, if I remove any one of the 3, especially any one of these 2, remember these 2 are strongly correlated with a strong linear relationship, then you might wonder, oh, if I drop income or if I drop population 15, would I commit underfitting? Because using theoretical thinking, the higher the income, the higher the consumption, and the more number of working age population members in the household, the higher the consumption. So you are scared, oh, if I remove any one of the 2 explanatory variables, will I commit a new problem, which is underfitting, which relates to chapter 13. Underfitting means you exclude some relevant explanatory variables. So in case you are scared of committing underfitting, you decide to do nothing. And then the other side of the story, if you are not scared of committing underfitting, then you can decide to drop an explanatory variables from the model. So for example, maybe you really decide to drop population 15 and refer back to the original regression. Remember, the original regression only includes price and income. So you can argue, I am not scared of committing underfitting. Then I decide to drop an explanatory variable, which is population 15. Third one, you increase the sample size. If you refer back to the given information, sample size was 31. So in this case, maybe you decide to increase to 50, maybe run the regression from the last 15 years. And then the fourth one, you rather decide to acquire a new sample. So maybe from another municipality. So currently, maybe you, from the original regression, you interview 31 households, maybe from Belleville municipality, but maybe the data quality is bad, then you decide to interview a new sample from a different municipality, maybe Bloberg municipality, as an example. Okay. And then the last 2 remedies can also be remembered together. I think I can delete the first 2 now to have more space. Okay, you can rethink the model. Do you think you can add more relevant explanatory variables? So for example, do you think rand-dollar exchange rate can also feature? Because if the rand is weak, it could have some impact on consumption, especially on imported goods. Maybe the rand becomes weaker, I would order less books from Amazon.com. I will consume less on books from Amazon.com. Okay, or maybe I can try different functional forms. For example, log of consumption. Strictly speaking, we should use log of consumption and log of income, actually. If you become a macro time series specialist, you would always notice when we run these types of regressions, we normally take log of income, log of consumption, double log function. Last one, we can transform the explanatory variables. The argument is that for these 2, why don't I rather have a variable called real per capita income? Okay. And then actually real per capita income is equal to income per person divided by household size. Obviously, we only include the working age population. So if I rather create a new variable, real per capita income, and I include this real per capita income variable, but rather take out the original income and pop 15 variable. Who knows, if I run the regression in this way, I can get rid of the imperfect collinearity problem. Okay, and then there are two more questions from the textbooks, and then 10.27, 10.28, and then if you have time, you can go through the answers on the slides. Okay, and then also work on the in-class exercises. Okay, so that's it. Then we will move on to chapter 11, heteroskedasticity, next week. See you then.